Dear students, in this video you will learn Gauss law in electrostatics. Gauss law is used to determine intensity of the electric field at a place due to a charge or a continuous charge distribution. Let us see what is Gauss law. From the definition of Gauss law is the total electric flux over a closed surface is equal to 1 by epsilon times the charge enclosed within the closed surface. That is, if we want to determine the electric flux through a closed surface, simply we calculate the charge inside the closed surface and divide it by epsilon naught. That is, electric flux pi E is equal to q by epsilon naught, or pi E is equal to integral E dot ds is equal to q by epsilon naught. In the last video, I already discussed the electric flux. Electric flux is the number of lines passing through the given surface in a direction normal to the surface in the electric field. And it is defined as pi E is equal to integral E dot ds. So let us see proof of the Gauss law. For this, I take a positive charge at O within a closed surface. Let us see the entire electric flux through this entire closed surface. For our convenience, I take ds area at P. Here, this arrow mark indicates the direction of the ds area. In Gauss law, we take the surface area is also the vector quantity. For this, we show its direction along the outward normal. That is in ds direction, and E is the direction of the electric field, and theta is the angle between the ds and E. And also one more quantity, that is d omega, which is called the solid angle. Here solid angle means the angle subtended by the surface at the center of the at the point, at the given that point. For our in this case, d omega, that is solid angle, is the um, solid angle made by this ds area at O, because plus q is placed at O. In this case, actually our question is to determine entire electric flux through the entire closed surface. But for our convenience, first we calculate the electric flux through ds area. Later, we simply integrate this and get the entire electric flux through entire area. For this, let us assume that d pi is the electric flux through ds area. Therefore, from definition, d pi e is equal to E dot ds, that is EDS cos theta. EDS cos theta. But we know from the definition of the intensity of the electric field, E is equal to 1 by 4 pi epsilon naught q by r square. Let us substitute this value into the above equation. Therefore, d pi E is equal to 1 by 4 pi epsilon naught q by r square. 1 by 4 pi epsilon naught q by r square into ds cos theta. Or we can write this as q by 4 pi epsilon naught into ds cos theta by r square. Here ds cos theta by r square is numerically equals to solid angle subtended by the ds area at O, which is already discussed. It is equal to dw. Therefore, we write dw instead of ds cos theta by r square. Therefore, the above equation is converted into d pi e is equal to q by 4 pi epsilon. Instead of ds cos theta, we write dw. So, d pi e is equal to q by 4 pi epsilon d omega is the electric flux through ds area. But our intention is to measure the electric flux through the entire surface. So let us integrate the above equation. Then we get the electric flux through the entire closed surface. Therefore, electric flux through the whole surface pi e is equal to integral d pi e. Here we substitute the d pi e value. Then the equation converted into pi e is equal to integral q by 4 pi epsilon naught d omega. లేదా q by 4 pi epsilon naught integral d omega. Here integral d omega is the solid angle subtended by the entire surface at O, which is numerically equal to 4 pi. Therefore, we write 4 pi in the place of integral d omega. Therefore, electric flux through the entire surface pi e is equal to q by 4 pi epsilon naught into 4 pi. Cancelling 4 pi, we get pi e is equal to q by epsilon naught. Q by epsilon naught. That is electric flux pi is equal to q by epsilon naught, or electric flux pi is equal to integral E dot ds is equal to q by epsilon naught. This is Gauss law in electrostatics. Let us see another form of Gauss law, which is called differential form of Gauss law. Let us see what is different for differential form of Gauss law. From the definition of Gauss law, pi is equal to q by epsilon naught. Here, q is the total charge enclosed by the entire closed surface. We write this q as q is equal to volume integral over v rho dv. Here, rho is the volume charge density, which is defined as rho is equal to q by v. Therefore, we substitute integral over v instead of q, and we use one more application, that is Gauss divergence law. Here Gauss divergence law is used to convert surface integral into volume integral. That is integral surface integral over s E dot ds is equal to volume integral over v rho dv. Therefore, using these two equations, that is Gauss law and Gauss divergence theorem, we can write pi is equal to integral E dot ds is equal to q by epsilon naught. Taking the last two terms, that is these two terms, we write as volume integral over v dv dv is equal to 1 by epsilon naught volume integral over v rho dv. Cancelling integral terms, we get dv dv is equal to 1 by epsilon naught rho. Therefore, we can write dv as del dot e. Therefore, del dot e is equal to rho by epsilon naught. Here, del dot e is equal to dv. By sending epsilon naught into left side, we get epsilon naught into del dot e is equal to rho, or del dot epsilon naught e is equal to rho. Here epsilon naught e is called displacement vector, which is denoted as d. Therefore, we write d instead of epsilon naught e. We get del dot d is equal to rho. This is the Gauss differential form of Gauss law. Thank you.